Welcome students, myself Kale, Rayat Shikshan Samstha RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 2nd, Chapter number 7, Limits, Exercise 7.1. In the previous video lecture, we have completed question number 1 and also we have seen basic of the limits. Now in this lecture, we start question number 2nd and question number 3rd. So let us try to solve question number 2nd. Evaluate the following limits, and first example is limit x tends to the 3 under root of 2x plus 6 upon x. Now while solving the examples on limits, we decide whether denominator is 0 for the value of x. Here x tends to 3 means in solving problem we put x as a 3. We know that when x tends to the 3, x not equal to 3, but it is very close to 3. So when we solve the problem, we put x as a 3. So solution of this, firstly write the given problem, that is limit x tends to the 3 under root of 2x plus 6 divided by x. So when we put x as a 3 in the denominator not 0, and so therefore directly put the value of x as 3. So this is equal to under root of 2, x is 3, so 2 into 3 plus 6 divided by x as a 3. So this is equal to under root of 2 3s are 6 and plus this 6 divided by 3. So it is equal to under root of 6 plus 6, that is 12 divided by 3. So it is equal to under root of, we write this 12 as 4 into 3 divided by 3. So if we take the square root of 4, it is 2. So 2 into root 3 divided by 3. This is the solution of this problem. Now second problem here. Second, limit x tends to 2. Limit x tends to 2. X to the power minus 3 minus 2 to the power x to the power minus 3 minus 2 to the power minus 3 divided by x minus 2. Now see here, firstly call this as, or write here limit as x tends to 2 and the given problem x to the power minus 3 minus 2 to the power minus 3 upon x minus 2. So when we put x is equal to 2 in the denominator, if we put x is equal to 2 and numerator 0, there is no problem for the numerator. Numerator may be 0, may not be 0, but denominator should not equal to 0. So when we put x is equal to 2, here 2 minus 2 0. So we have to solve this problem. Either we use here formula or we use other any trick to solve the given problem. So we have one formula, that is limit as x tends to a. Limit as x tends to a, x to the power n minus a to the power n upon x minus a. Here limit x tends to a, in the denominator x minus a, and in numerator x to the power n minus a to the power n. Power should be same. Then the here solution is, we are interested here in a to the power n. We write here a to the power n and then take this n here and minus 1. So n into a to the power n minus 1. So this is equal to, use same formula here, powers are same, minus 3 minus 2 1, and divided by here x tends to 2, x minus 2. Then we use n into a to the power n minus 1, that is take this 2 to the power minus 3 as it is, this minus 3 here, and then minus 1. So it is equal to minus 3 into 2 to the power minus 4. 2 to the power minus 4. So it is equal to minus 3 into 1 upon 2 to the power 4. Using the rule of indices, a to the power minus m is equal to 1 upon a to the power m. And so it is equal to minus 3 into 1, that is minus 3 divided by 2 to the power 4. Okay, 2 to the power 4 means here take the product of 2 4 times, that is 2 into 2 into 2 into 2. So it is minus 3 upon 2 to the 4, 4 to the 8, 8 to the 16. So this is the solution for the second problem. Now third problem here, limit x tends to 5. Limit x tends to 5. X to the power 3 minus 125 divided by x to the power 5, x to the power 5 minus 3125, 3125. So consider this problem. So this is equal to limit as x tends to 5, x to the power 3 minus 125 divided by x to the power 5 minus 3125. So it is equal to limit as x tends to 3. In the numerator here x to the power 3 means this 125 is also the third power of something. Here power 3, so here should be power 3 of which number? Here x tends to 5. So this 125 is 5 to the power 3. We may check here. Here we write this as 5 to the power 3. 5 to the power 3 is equal to 5 into 5 into 5. 5 5 is 25. 25 5 is that is 125. So in this way here, this 125 is the third power of some number, and that number here, since limit is x tends to 5, so it should be 5 to the power 3. Get it? Now here in denominator x to the power 5 means minus here 3125, it is the fifth power of some number. Here x to the power 5, so this is also fifth power of which number? Here x tends to 5. So surely here 5 to the power 5, 5 to the power 5, this should be 3125. Take the product of here 5 to the power 5 is equal to 5 into 5 into 5 into 5 into 5. 5 5 is 25. Here 5 5 is 25 into 5. 25 is it is 625 into 5, and here 5 5 is 25 to 5 2 is 10, 10 and 2 12, 1, and 5 6 is 30 and 1 3 31. So in this way here 5 to the power 5, 5 to the power 5 is 3125. And now we have formula. Which formula? Limit as x tends to a. Since formula is here, limit as x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. We have to use this formula. But in the numerator there is x to the power 3 minus 5 to the power 3. So it should be divided by x minus 5. Also in the denominator x to the power 5 minus 5 to the power 5, it also should be divided by x minus 5. So here we divide numerator and denominator by same number x minus 5, so that we use the formula in the numerator and denominator separately. So here this is equal to x to the power 3 minus 5 to the power 3, and here in the denominator x to the power 5 minus 5 to the power 5. So divide this by x minus 5, also divide this by x minus 5, and here write dividing numerator and denominator by x minus 5, and then take limit to numerator and denominator separately. So limit as x tends to 5, limit as x tends to 5, and here also limit as x tends to 5. Means we have to use this formula in the numerator separately and also in the denominator separately. What is your formula? N into a to the power n minus 1. So it is equal to this 5 to the power 3. Here 5 to the power 3. Take 3 here, 3 into, and subtract 1 from the power, that is 3 minus 1. Here 5 to the power 5, take here 5 to the power 5, okay, and then take this 5 as a coefficient and subtract here 1. This is the formula, using this formula. So it is equal to, we get here 3 into 5 to the power 3 minus 1, it is 2, divided by 5 into 5 to the power 5 minus 1, it is 4. Okay. Now here we get 3 divided by 3 into 5 to the power 2 divided by 5 to the power this 1 power and this 4 power. So 1 plus 4, it is 5. Okay. So here it is equal to 3 upon 5 to the power. We carry this 2 power in the denominator. That means we write here 5 minus 2 using the rule of indices. And so we get here 3 upon 5 to the power 5 minus 2. 5 minus 2, it is 3. So 3 upon here 5 to the power 3 means 5 into 5 into 5. So we get here 3 upon 5 5s are 25 and 25 5s are, that is equal to 125. So here solution of this third problem is 3 upon 125. Now next here fourth problem. Fourth problem here, limit x tends to 1. Limit x tends to 1. X to the power 4 minus 1 upon x minus 1 is equal to, limit as x tends to a, limit as x tends to a, x to the power 3 minus a to the power 3 divided by x minus a. Find all possible values of a. Find all possible values of a. Okay. Now write here problem, given problem. So solution of this, limit as x tends to 1, x to the power 4 minus 1 divided by x minus 1 is equal to, limit as x tends to a, x to the power 3 minus a to the power 3 upon x minus a. Now we have the standard formula. Which formula? Limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. We use this formula on the both sides. Here x to the power 4 minus 1. We write here 1 as 1 to the power 4. We write here 1 as 1 to the power 4 because power should be same. And 1 to the power anything that is equal to 1. So we adjust here 4. And now therefore using this formula n into a to the power n minus 1. We are interested for this value only on the both side. So we get here 4 into 1 to the power 4 minus 1. Carry this 4 and then 1 to the power 4 minus 1 is equal to, here 3 into a to the power 3 minus 1. Okay. So we get here 4 into 1 to the power 4 minus 1, that is 1 to the power 3. 1 to the power 3 is 1. And now here is equal to 3 into this. 3 into, so carry this 3. So 3 is in the denominator and is equal to a to the power 3 minus 1, it is 2. Now here 4 upon 3, a square is equal to 4 into 1, 4 upon 3. So a is equal to plus or minus, we take here square root. So a is equal to plus or minus under root of 4 upon 3. And therefore we get here a is equal to plus or minus, we take the square root of 4, that is 2, divided by here square root of 3, we write as it is, root of 3. And therefore a is equal to 2 upon root 3, or a is equal to minus 2 upon root 3. These are the possible values of a. These are possible values of A. So this is the solution of the fourth problem. Now we see here question third. In this way we completed here question second. Now we start here question third. Question third, same question. Evaluate the following limits. Here question third, evaluate the following limits. First problem, limit as x tends to 1. First, limit as x tends to 1. X plus x square plus x cube in the numerator, x plus x square plus x cube plus up to dot 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 plus x to the power n minus here n divided by x minus 1. We have to solve this problem. So solution of this, we write this problem again, that is limit as x tends to 1, x plus x square plus x cube plus up to dot 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 plus x to the power n minus this n and divided by x minus 1. Now see here, limit as x tends to 1. When we put x as 1, it is 0. So denominator 0, so we have to remove this difficulty by solving the problem. Now how to solve? Now here we write this n. Suppose here 2, here suppose 2. We write 2 as 1 plus 1. Suppose here 5, we write 5 as 1 plus 1 plus 1 plus 1 plus 1. Means here take the addition of 1 5 times. 1 plus 1. That means 1, 2, 3, 4, 5. 5 times 1. Now here there is n. So we write n as n is equal to 1 plus 1 up to dot dot n times. We take the addition of 1 n times. And so here it is equal to limit as x tends to 1. This part x plus x square plus x cube plus up to dot dot plus x to the power n as it is, here minus sign, and in the bracket we write 1 plus 1 plus 1 plus up to dot dot n times. Here it is n times and divided by x minus 1. Divided by x minus 1. So it is equal to limit as x tends to 1. Limit as x tends to 1. Now we take here this x and this 1 minus 1. We multiply by minus sign inside the bracket. Then it is minus 1 minus 1 minus 1 so on n times minus 1. So we take here x and this minus 1. Then again this plus x square, next minus 1, then here plus x cube, then this one with minus sign, that is x cube minus 1, plus up to dot dot, lastly this x to the power n and last minus 1 and divide by totally x minus 1. Divide by x minus 1. Okay. Now we divide by separately x minus 1 to every terms in the numerator. And so we get here a limit x tends to 1. Here x minus 1 upon x minus 1. Okay. Here x square minus 1 upon x minus 1. Here x cube minus 1 upon x minus 1. And lastly here x to the power n minus 1 upon x minus 1. And here plus sign. Okay. Here plus sign. And lastly here also plus sign. And take limit to every term. We take here limit to every term. So we write here limit as x tends to 1. Here also take limit as x tends to 1. Here also take limit as x tends to 1, and here also take lastly limit as x tends to 1. Now here x minus 1 and x minus 1 get cancelled. Now here we have to use that standard formula. Which formula? Limit as x tends to, here since limit x tends to a, x to the power n minus a to the power n upon x minus a is equal to n into a to the power n minus 1. Okay, so here power power 2, therefore we take here power 2, 1 to the power 2. No problem, because 1 to the power anything, that is equal to 1. Here power 3 we take 1 to the power 3. Here power n, here we take 1 to the power n, same power, and then use the formula. So here x minus 1 get cancelled, here remains 1. So limit x tends to 1. We want to put the value of x as 1, but here there is only 1 is constant. There is no x, so we write that as a 1. So it is equal to 1 plus. Now here use the formula. We use formula and we use this 1 square, here 1 cube, here 1 to the power n and so on. So n into a to the power n minus 1. N here 2. So 2 into a means 1 to the power a minus n minus 1 means 2 minus 1. Okay. Plus next, here, this 1 to the power 3, we write 3 into 1 to the power 3 minus 1, plus up to dot dot, lastly here this n into 1 to the power n minus 1. Okay, so we get here 1 plus 1 to the power anything, or we may write 2 into 1 to the power 2 minus 1, 1, plus 3 into 1 to the power 3 minus 1, 2, plus up to dot dot, plus n and 1 to the power n minus 1. But we know that 1 to the power anything, that is equal to 1. Okay, 1 to the power 1, that is 1, 1 to the power 2, 1, 1 to the power n minus 1, it is 1. And therefore we get here 1 plus 2 into 1, that is 2, plus 3 into 1, 3, plus and so on, plus n into 1, that is n. So this is the addition of the first n natural number. And we have seen in the school level, this addition is n into n plus 1 divided by 2. We have seen this formula. In sequence series also we have seen addition of first n terms, that is equal to n into n plus 1 divided by 2. This is the final solution of the first problem in question number 3rd. Now question number 2nd. Limit x tends to 7. Limit x tends to 7. Cubic root of x minus cubic root of 7 divided by, here again next term is cubic root of x plus cubic root of x plus cubic root of 7 and divided by here x minus 7. Okay, if we put directly x as 7, then denominator 0, so we have to remove this difficulty. And then when there is denominator not equal to 0, while putting x is equal to 7, then we put directly x is equal to 7 in the problem, or we may use here formula. Okay, so solution of this, we start solution from here. Okay, so we write this as limit as x tends to 7. This cubic root of x, we write x to the power 1 by 3. X to the power 1 by 3 minus 7 to the power, here also 1 by 3. And divided by this x minus 7. We use here formula. Powers are same. Here x7, here x7, x tends to 7, x minus 7. So we use here formula. But what here? Now here we write x to the power 1 by 3. Cubic root of x, we write power 1 by 3. Plus same here 7 to the power 1 by 3. Okay. And now we separate the limit to both the terms. We separate the limit. So we write here into limit as x tends to 7. Here denominator is 1, so denominator not 0, so we put directly x is equal to 7 here in the second part. In the first part, denominator is 0, while we put x is equal to 7, denominator is 0. So we use here standard formula. Which formula? We have written here limit as x tends to a, x to the power n minus a to the power n upon x minus a is equal to n into a to the power n minus 1. Very important formula. We use many times in this exercise. So use standard formula here, and here put directly x as 7. So it is equal to 7 to the power 1 by 3, and take here this 1 by 3 as a coefficient, and then minus 1 by 3 minus 1 into here into we put x as 7. X as 7 means 7 to the power 1 by 3 plus here 7 to the power 1 by 3. So we get here this 1 by 3 as it is, 7 to the power 1 by 3 minus 1, that is 1 minus 3. 1 minus 3, that is 1 minus 3 upon 7. 3. Here 3. 1 minus 1 into 3, 3 upon this 3. Into here 7 to the power 1 by 3 plus 7 to the power 1 by 3, it is 2 into 7 to the power 1 by 3. Okay, that is suppose here 7 plus 7, that is 2 into 7, that is 14. So we get here 2 into 7 to the power 1 by 3. So here it is equal to 1 by 3. This 7 to the power 1 minus 3, that is minus 2 by 3. And this 2 into 7 to the power 1 by 3. Okay, so we get here 1 by 3 into 2, that is equal to 2 upon 3. This 1 by 3 into 2, 2 upon 3, and here 7 to the power minus 2 by 3 and 7 to the power 1 by 3. So we write here 7 to the power minus 2 by 3 and plus 1 by 3. Minus 2 by 3 plus 1 by 3. Okay, so it is equal to, we get 2 upon 3, 7 to the power, here denominator is same, that is 3, and minus 2 plus 1, minus 2 plus 1, minus 2 plus 1, it is equal to minus 1, minus 1 by 3. And so the final solution is, here this power, minus power we write positive, we take in the denominator, that is 2 upon this 3 into 7 to the power 1 by 3. 2 into 7 to the power 1 by 3. So it is equal to 2 upon 3 into this 7 to the power 1 by 3, that is cubic root of 7. So 2 upon 3 into cubic root of 7. So this is the final solution for second problem. So now next third problem. Third problem, limit x tends to 5. Third, limit x tends to 5. X to the power k minus 5 to the power k upon x minus 5 is equal to 500. Find all possible values of k. Find all possible values of k. Okay. Now see here, we have given limit x tends to 5, limit x tends to 5, x to the power k minus 5 to the power k divided by x minus 5 is equal to 500. Now on the left hand side, in the denominator, if we put x is equal to 5, we get 5 minus 5, that is 0. So we have to solve this problem, or we have to use formula. So we use here standard formula, limit x tends to a, x to the power n minus a to the power n upon x minus a is equal to n into a to the power n minus 1. Powers are same, power should be same, x 5 and x tends to 5. So formula is 5 to the power k, this k here and minus 1. Okay, so it is equal to, we write this 500 as 4 into 125, 4 into 125. So we take here k into 5 to the power k minus 1 is equal to 4 into, here 5 to the power, this 125, 5 to the power 3, 5 into 5 into 5, 5 5s are 25, 25 3s are 125, and this 3 we write here k minus 1, so here 4 minus 1, here k into, and power is k minus 1, here 4 into 5, this 5 to the power, this 4 minus 1. So comparing both sides, we get k is equal to 4, k is equal to 4. So this is the solution of the third problem. Now next, fourth problem, limit x tends to the 0. Fourth problem, limit x tends to the 0, 1 minus x to the power 8, 1 minus x to the power 8 minus 1 divided by 1 minus x to the power 2, 1 minus x to the power 2 minus 1. This is the problem. Now here, when we put limit as x tends to the 0, means if we put here x is equal to 0, what we get? X is equal to 0, so 1 minus 0, that is 1 square, 1 minus 1, 0. So denominator becomes 0. So we have to solve this. We cannot put directly x as a 0. So how to solve this problem? Now here we use here substitution method. Suppose here we put 1 minus x, put here 1 minus x is equal to new variable, suppose y. We put here 1 minus x as a y. Now here limit as x tends to the 0, and when we take the substitution method, then we have to change limit using this equation. Here x is 0, if we put here x is 0, then we get y is equal to 1. So when x tends to 0, x tends to 0 means put here x is equal to 0 in this equation, x is equal to 0, so 1 minus 0, 1 minus 0, 1, so we get y as a 1, means y tends to 1, and then we write this limit as, therefore we write this limit x tends to the 0, 1 minus x to the power 8 minus 1 upon 1 minus x to the power 2 minus 1, and now use here substitution. So limit y tends to 1 now, and here write 1 minus x as y, so y to the power 8 minus 1 divided by, in the denominator 1 minus x as y, so y to the power 2 minus 1. And now here again if we put y is equal to 1 square, that is 1 minus 1, 0, again we have to solve. We have to use here formula now. In the denominator and in the numerator, in numerator and denominator, we use separate formula. Which formula? Limit as x tends to a, x to the power n minus a to the power n upon x minus a, that is equal to n into a to the power n minus 1. But here we must have in the denominator y to the power 8 minus 1 divided by y minus 1. Also in the denominator here also y minus 1. So we should divide numerator and denominator by y minus 1. So here we write divide numerator and denominator by y minus 1. Divide numerator and denominator by y minus 1. So we get here y to the power 8 minus 1 divided by y minus 1. Also in the denominator y to the power 2 minus 1 divided by y minus 1, and write limit to numerator and denominators separately, that is limit y tends to 1, and here also limit y tends to 1. Now here y to the power 8 minus 1, we write 1 to the power 8, because here 8th power, here also we must have 8th power. Write here 8 because 1 to the power 8 is 1. Here y to the power 2, here also write 2 to use this formula. And so we get here, this is equal to, now here 1 to the power 8 and here 1 to the power 2. We have to use these only. Means n into a to the power n minus 1. So 8 into 1 to the power 8 minus 1 in the numerator, and in the denominator 2 into 1 to the power 2 minus 1. So here 1 to the power anything, that is 8 into 1 to the power 7, that is 1 upon 2 into 1 to the power 2 minus 1, 1 to the power 1, 1. And here 2 ones are 2, 2 fours are 8. So solution is 4. So in this way here we have completed 4th problem. Next, 5th problem. 5th problem here, limit x tends to the 0. Limit x tends to 0, cubic root of 1 plus x minus cubic root of 1 plus x divided by x. Okay, now see here solution of this. If we put directly x as 0, then denominator is 0. Now here also we use the substitution method. Put here 1 plus x as a y. We put this 1 plus x as y. Now when we use the substitution method, we have to change this limit. As here x tends to the 0, means put here x is equal to 0 in this equation. So 1 plus 0, that is 1. So we get y as a 1, means y tends to 1. And now write this problem again. Let, that is limit x tends to 0, cubic root of 1 plus x minus cubic root of here also 1 plus x divided by x. Divided by x. Here cubic root of 1 plus x and here square root. Here we have not given number. Otherwise this and this get cancelled to each other. Here square root. Okay. Here we change this. So this is equal to limit as, now we take y tends to 1. Y tends to 1. And cubic root of 1 plus x we write y. Minus here square root 1 plus x as y, and divided by here x. X we write here from this equation, x is y minus 1. We carry this 1 here. So y minus 1. From this equation x is equal to y minus 1. And now it is equal to limit as y tends to 1. Here cubic root of y means y to the power 1 by 3. Minus here y to the power square root means power 1 half divided by y minus 1. And if we want to use formula, limit x tends to a, x raised to n minus a raised to n divided by x minus a, it is equal to n into a to the power n minus 1. This is the formula. So here limit as y tends to n, y tends to 1, and here y minus 1 means here x raised to n minus x raised to 1 by 3 minus 1 raised to 1 by 3 should be here. So we take here minus 1 and plus 1. So it is equal to limit as y tends to 1. If we want to use this formula, see here in the denominator x minus a, So x to the power minus a to the power n should be in the numerator. Here in the denominator y minus 1. So here y to the power 1 by 3 minus 1 to the power 1 by 3. But here y to the power 1 half. So we want here 1 to the power 1 by 3 to this term, and here 1 to the power 1 half to this term. So we minus and plus 1. So we take here y to the power 1 by 3 and this minus y to the power 1 half and this y minus 1 as it is. Now here we take minus 1 and here we take plus 1, so that minus 1 and plus 1 get cancelled. And now here it is equal to limit as y tends to 1. Here y raised to 1 by 3 minus 1, and here take minus sign common, minus in the bracket y raised to 1 half, and this plus 1 become minus 1 and upon y minus 1. Okay. Now we divide this y minus 1 separately to this term and this term, and also take limit y tends to 1 to both the term. So we get here y to the power 1 by 3 minus 1 divided by y minus 1 minus here y to the power 1 half minus 1 divided by y minus 1. Here take limit y tends to 1, limit as y tends to 1. Here also take limit as y tends to 1. Here y to the power 1 by 3, here take 1 by 3 because 1 to the power anything is 1. Here y to the power 1 half, here take 1 half. Okay. And now use here standard formula, this formula, limit x tends to a, x raised to n minus a raised to n upon x minus a is equal to n into a to the power n minus 1. That means here we have to use this term, means use this term and this term. Here we write this 1 to the power 1 by 3, this 1 by 3 here, and take here minus 1. Now this minus sign, here 1 to the power 1 half, take here this 1 half here, and 1 half minus 1. Now 1 to the power anything, 1 to the power anything, that is 1. So 1 by 3 into 1 minus 1 half into 1 to the power anything, that is 1. So we get here 1 upon 3 minus 1 upon 2. Okay. Now it is equal to 1 into 2, 2 minus 3 into 1, 3 divided by 2 into 3, 6. So it is equal to 2 minus 3, it is minus 1, so minus 1 upon 6. This is the solution for this fifth problem. Now here we see sixth problem. Sixth problem here, limit y tends to 1, limit y tends to 1, 2y minus 2, 2y minus 2 divided by cubic root of 7 plus y, cubic root of 7 plus y minus 2, minus 2. So solution of this, solution we write from this step directly, and we put here equal sign. So limit as y tends to 1. Now in the denominator when we put y as 1, so we get here, if we put here y as 1, 7 plus 1 that is 8, and cubic root of 8 is 2, and 2 minus 2 0, that means denominator become 0. So we have to solve this problem by formula method or by any other method. We cannot put directly y as 1. So we write here cubic root of 7 plus y to the power 1 by 3, and this 2, this is also cubic root of something. Since 7 plus y is a cubic root, so 2 is also cubic root of some number. If we take cubic root of 8, cubic root of 8, that is equal to 2. Cubic root of 8, that is equal to 2, means 8 to the power 1 by 3 is equal to 2. Okay, so we write this 2 as, 8 to the power 1 by 3. And in the numerator here 2y minus 2, so we take here 2 common, 2 in the bracket, y minus 1. 2 in the bracket y minus 1. And now here if we want to use standard formula, it should be divided by y minus 1, because here limit as y tends to 1. So we get here limit as y tends to 1, 2 upon this 7 plus y to the power 1 by 3 minus 8 to the power 1 by 3, and divided by this y minus 1, divided by denominator by y minus 1. Similarly divide the numerator by y minus 1, this y minus 1 and upon this y minus 1. This y minus 1 get cancelled in the numerator. So only 2 remains in the numerator. Okay, so 2 upon here 7 plus y to the power 1 by 3 minus 8 to the power 1 by 3 divided by y minus 1. Now here limit as y tends to 1, limit as y tends to 1, 2 upon 7 plus y to the power 1 by 3 minus 8 to the power 1 by 3, and divided by, we write this y minus 1 as a 7 plus y minus 8. We get here, we write this y minus 1, this y minus 1 as a 7 plus y minus 8. 7 minus 8, that is minus 1. And now use here standard formula, because as y tends to 1, as y tends to 1, y tends to 1, so 7 plus y, therefore here we add 7 on both sides, 7 plus y tends to 7 plus 1. Okay, that means 7 plus y tends to 8, means y tends to 1 is similar to 7 plus y tends to 8, because if we consider the formula limit as x tends to a, x to the power n minus a to the power n upon x minus a. See the situation of formula, x to the power n minus a to the power n divided by same x minus a. Here 7 plus y to the power 1 by 3 minus 8 to the power 1 by 3 divided by 7 plus y minus 8, means this x and this a same, but this tends to a here, x tends to a here, means 7 plus y tends to 8 should be here. Okay, 7 plus y tends to 8 should be here. Now as y tends to 1, we add 7 on both sides, so 7 plus y tends to 7 plus 1 8. So as y tends to 1 is the same as 7 plus y tends to 8, and therefore we use this formula. Formula is n into a to the power n minus 1. So here we may write here in this step we take limit to numerator and denominator separately, limit as y tends to 1, and in the denominator also limit as y tends to 1. Okay, so here in the numerator limit y tends to 1 2, here y is not present, 2 is constant, so we write 2 as it is, and here use the formula n into a to the power n minus 1. We are interested in this term, so 8 to the power 1 by 3, take here this 1 by 3 and minus 1. So here solution is 2 upon this 1 by 3, or we may write here 2 into this 1 by 3, we write 3 by 1 into 1 upon this 8 to the power 1 minus 3 into 1 3 and divided by 3. So it is equal to 2 into 3 6, 6 into 1 upon 8 to the power 1 minus 3, 1 minus 3 means minus 2, so minus 2 by 3. Okay, so we write this as 6 into, carry this 8 to the power minus 2 by 3 in the numerator using the rule of indices, we get here 8 to the power 2 by 3. Now here 1 by 3 means cubic root, so it is equal to 6 into cubic root of this 1 by 3 power. Here 2 2 by 3 we write 2 into 1 by 3, and that 1 by 3 means cubic root of 8 square, cubic root of 8 square. Okay, so it is equal to 6 into cubic root of 8 square means 8 square means 64, and cubic root of 64, that is 4. So 6 into 4, 6 into 4, and 6 4s are 24. So we have the solution of this sixth problem as 24. So now next problem, here two problems we have to take. Seventh problem, limit as z tends to a, limit as z tends to a, z plus 2 to the power 3 by 2 minus a plus 2 to the power 3 by 2 divided by z minus a. This is the problem. Now here solution of this, we write solution from this step. Take here equal sign. Limit as z tends to a, we write here numerator as it is z plus 2 to the power 3 by 2 minus a plus 2 to the power 3 by 2. Powers are same, and in our standard formula limit x tends to a, x to the power n minus a to the power n. Powers are same here. Here n, here 3 by 2, here 3 by 2. Here x and a. Z plus 2, a plus 2. Okay. So in the denominator here x minus a. In the denominator x minus a. Means in the denominator here should be z plus 2 minus a plus 2. We take here z plus 2 minus a plus 2, because when we solve this z plus 2 minus a plus 2, we get it is equal to z plus 2 minus sign minus a and minus 2. This minus 2 and plus 2 get cancelled, so we get z minus a. So we take the subtraction of these two and directly now use the formula. But here divided by x minus a, and x should tends to a. Here this z plus 2 should tends to a plus 2, but we have given z tends to a. Now here since z tends to a, we add 2 on both sides. Therefore z plus 2, add here 2 and here also 2. Z plus 2 tends to a plus 2. So z tends to a is the same as z plus 2 tends to a plus 2, and so therefore we use that formula. Means here we write from this term the formula as it is equal to this a plus 2 to the power 3 by 2. Take this power 3 by 2 here and minus 1. Okay, so it is equal to this 3 by 2 a plus 2, 3 minus 2 into 1, here 2. Here it is 2. 3 minus 2 into 1, that is 2, and upon 2. So final answer is here 3 by 2 a plus 2 to the power 3 minus 2, that is 1/2. And power 1/2 means right in the square root sign. So it is equal to 3 upon 2 into root of a plus 2. This is the final solution. So in this way we have completed here 7th problem. Now 2 problems remains in the question number 3rd, and we stop here. We see these 2 problems in the next video lecture. Okay, we stop here.